JavaScript inheritance. So we will talk about these two topics: inheritance through prototype and function constructor and prototype. So inheritance through prototype. So in programming languages, there are two different ways for supporting inheritance. So if you're coming from Java, C, and C++ background, those languages have a concept of class. Okay, and so inheritance is supported through class hierarchy. So you have a parent class, and then you have a child class inherited from the parent class, and object created from that child class inherit all the properties and methods of the parent class. So that's how the Java and the C++ works. However, the second scheme of supporting inheritance is through prototype, because JavaScript does not have a concept of class. Okay, so it should support inheritance, and it does support inheritance through prototype. So let me explain what that prototype in a few minutes. So JavaScript is prototype based language, meaning it will support inheritance through prototype. Okay, so as I said, in a prototype programming language, there is no concept of a class. Okay, so inheritance is going to be provided through prototype. So how does prototype language support inheritance? So in prototype language, every object has a prototype property. The actual name of the field is going to be __proto__. Okay, so we're going to actually, refer to this guy as a prototype property. Okay, so it actually refers to another JavaScript object. Okay, and that object is also JavaScript object. It also has this prototype property, right? Okay, so since the prototype object itself is a JavaScript object, it has its own prototype property, which in turn forms prototype chain until it reaches object property, which is a null as a prototype. Okay, so key point on this slide is that in JavaScript, it doesn't have a concept of a class, meaning everything is an object. Okay, and the way it does support inheritance is through what is called the prototype property. Okay, so let me explain how that works. So it's pretty simple concept. If an object itself does not have a property, okay, and if that property is requested, then prototype objects in the prototype chains are searched. Okay, so let's say there is a JavaScript object. There is a JavaScript object called the my object, and let's say it has a property A. Okay, so in this case, when you are referencing my object.a, it will get the value of property A from my object. That's no problem, right? Now, suppose my object does not have property B, okay? Yet my object.b is being referenced. In this case, it will try to trigger the search of this B property in the property chain of my object. So if any object in the property chain has this property B, that will be returned. So that's basically what I said here. If one of the prototype objects in the prototype chain has a property of B, then my object B will return the value of it. Okay, so prototype objects in the prototype chain can capture the shared properties, thus provide inheritance. So this is how prototype-based languages support inheritance. They actually do this through what is called a prototype. Okay, so let's take a look at an example. As I said before, every single JavaScript object has this prototype property, which is actually represented again __proto property. So this is the actual name. Okay, so suppose if you have a JavaScript object of foo. So we have a JavaScript object. We have a two key value pair, x equal x10 and y20, and we assign to foo. So if you dissect, if you actually inspect this full object, we are going to see these two properties, x and y, which contains a value of 10 and value of 20. It does have underscore property, and this is actually forming a the prototype chain. Okay, so in fact, if you go to any object, right? So if I go to let's say what could be, I'm just use an example somewhere. So this one, so so if you see any object, you are going to see this underscore prototype property. Okay, any JavaScript object. Okay, F12. So in this case, you are going to see in fact proto. Yeah, so this is the field. Okay, and Windows should have that one as well. So if you go all the way down there, you are going to see in fact this guy, underscore proto. Okay, so every JavaScript object has this underscore proto property. Okay, all right. Okay. So underscore property, we're gonna call it prototype property. Okay, we can actually manually set the value. Okay, so in this case, we're gonna do some experimentation. We have JavaScript object A, which contains x and calculate method. Okay, so calculate method will access value x property and the y property and the z, that is an argument. Okay, now we have created another JavaScript object B, and we are going to manually set underscore to A. Okay, so we're going to actually create the B object, and we are going to explicitly set this proto property with A. So basically, we are constructing a prototype chain. Okay, and the C, we create a C object, and we are going to set this prototype field, to A, like this. Okay, so this one and this one is actually, you're basically setting proto field with A. So what we are going to see is that the proto field of B is referencing A object, and proto field of C is also referencing A object, and A object has X and calculate, and the A also has proto field because it's a genuine JavaScript object, and because it's not set to any other object, it actually references to object. Okay, which in this case proto is set to null. Okay, now because B and C contains this prototype field set with A, what we can do is that we can call calculate method of B, and the value is going to see is, so in this case it will return 60. Okay, because it will execute this code. X is 10, and in this case y is, for the case of B, y is 20, and it's passing 30, so it will return 60. In the case of C, when you call calculate method, okay, because calculate method is not in the C object, right, it will search for prototype chain. So it actually goes through this chain, and it finds there is a calculate method, so it's going to call this calculate method. Okay, so same thing with the B, right? So in this case, it will access value X, okay, 10, and Y in this case set to 30, and the 40 is argument, so it will return 80. Does this make sense? Any questions on slide 7? Any questions on this slide 7? Any other questions on this slide 7? moving forward. Okay, now this underscore proto underscore field is not a standard, even though pretty much all JavaScript implementations, including JavaScript implementations of Chrome browser and Firefox, supports it. Okay, but it is not a standard. So ECMAScript 5 compliant JavaScript engines now provide standard way of accessing this internal prototype field. They actually provide this API, get prototype. So as part of the object JavaScript method. So this is in fact the same thing as this. So if you have a JavaScript object called the myObject, you can call object.getPropertyType of myObject. This will return the same thing as underscore proto field. Okay. Okay, so let's do exercise 1. So exercise 1. Okay, so I'm gonna open the lab documentation. So this is basically what I showed you in the slide. So we define foo object, and if you inspect, so let's actually try this. Open folder, and so labs inheritance and sample files. Okay, so prototype chain, so this is the one. Okay, so what we do is that we are going to create a JavaScript object, and then we are gonna inspect it. Okay, so let's inspect it first. Okay, so click live preview and F12. So this is the one. So you can see if you inspect this guy, this is an object. It does contain X and Y, and then it does contain proto field, and it actually points to object, okay, which is which contains the null value on its own proto field. Okay, all right. So that is X and Y and proto field. Okay. All right, so now, so we inspect any JavaScript object, and any JavaScript object should have the prototype field. And so note that toString method is not present in the foo object. So you can actually call toString method of foo object even though it is not a method. It is not a property of foo object. You can still access it. So if you actually go over here, you can still access you can still access. toString is in fact the a function object, and we can actually call that toString. Yeah, this is the function object, and this is actually result of calling toString object. Okay. In either case, it doesn't say, oh, that property is not present. The reason is because it actually goes through the proto chain, and this is in fact the method, a property of object. So let's actually go over here. So you can see there is a toString property of this the object in the prototype chain. So we have toString, and there are value of and things like that. Okay. All right. And then we are going to display prototype chain. So we can actually go from the foo, and we can display proto field underscore proto. Then it should actually return object, right? So that's what gets returned. It actually returns this one. It returns the object. Okay. Now, if you actually go, let's see, if you go to proto, then this is in fact the object, right? Object proto field is null. Okay. And in this case, if you go one more, then obviously it's not gonna it's not gonna actually say, because it should have invalid field or something like that. So let's actually try that. If you do that, then you're going to see, yeah, so there is no _product field from the null object. Okay, so obviously this is not going to work. Okay, all right, so that is exercise 1. So I'll give you guys 10 minutes to try this exercise. Okay, so now let's talk about constructor function and again the concept of prototype. So what we have done in our previous example is that we construct inheritance relationship between object instances. Okay, but what we want is to provide inheritance relationship for a group of objects. Okay, so in our previous example, we had to manually set the prototype field of a particular object. Okay, so in Java, all objects of a child class inherit properties and methods of a parent class. So what we want to do is pretty much the same thing. In JavaScript, we want all objects created from a constructor function to inherit all properties of that constructor function. So if you remember, we were able to have a constructor function, and then we were able to create an object using a new keyword from that constructor function. Okay, so basically what we want to do is that any object instances that gets created from the constructor function using new keyword should have the properties of that constructor function. Okay, so that is what we want to do. Now, object created through constructor function. So besides creating object, a constructor function does another useful thing. It automatically sets a prototype object for newly created object. Let's see. You guys having a problem with the sound? I think Servlet says the sound is lost. Can you guys hear me okay? Yeah, it looks like several people actually complain about the sound is being lost often. Okay, so it automatically sets the prototype object for newly created objects. So let me explain what that means. This prototype object is stored in prototype property of constructor function. So this is different from __ prototype property. So the terminology of a prototype is in fact the overloaded. I mean, we are using the same thing for several purposes. Yeah, so it could be another the aspect of confusion. But in this case, what we are talking about is another field called the prototype, and that's completely different from __ proto property. Okay. So when JavaScript object is created from a constructor function, all properties and methods of the prototype object for the constructor, meaning the object of this guy, is attached to the resulting object. Now, you don't really have to understand the internal mechanics in order to use the prototype effectively. So let's actually talk about how we can actually use this prototype field first. And this is a usage model, and this is something that you certainly want to understand, right? But how it is done underneath is not something that you have to understand. Okay, so this is a usage model of prototype field of constructor function, and this is something you want to understand. So suppose we have a function constructor called the foo. Okay, now what you can do is, for this constructor function, you can use a prototype field. Okay, so you are adding prototype field, and then you are setting x field of that object to 10. And you can also add a method. So this is the case that you are adding a property whose value is 10. You are also adding a method. Okay, so here I'm adding calculate method through prototype. Okay, so this function constructor now has a prototype field that contains x and calculate properties. Okay, so now if we created new object from this foo constructor, so here I'm creating foo constructor and I'm assigning to variable b, and here I'm creating another one, c, and then when I call calculate method, okay, it will result 60 and 80. So if you think about our previous case, we had to set underscore proto field, okay, manually to construct inheritance relationship between object, right? Here we want to create inheritance relationship for all objects that are created from this function constructor. So in this simple example, it will result the same, but when I create another foo object, that will in fact inherit this x and calculate. Okay, so you know the var d equal new foo 40, and that should actually, I should be able to say d colon calculate, and that should work fine. Okay, so if you actually see internals of this guy, okay, so when you do create a function constructor like this, okay, all right, and then when you create new object here, it basically adds another field called the prototype, okay, like this. And any properties that you are going to add like this, x and calculate, will be in fact an object of its own that contains x and calculate. And then the proto underscore proto field is now pointing to this guy. So this is the way every time you're creating a brand new foo object, it always, this proto underscore field will always point to this prototype object. So that's the reason any object gets created from the foo constructor will inherit the properties of this guy. Does this make sense? So again, the internals of this one is probably not that critical for you to understand. You know, basically all you have to understand is that for function constructor, you can just use prototype field. Again, that's different from underscore proto field, right? So you can just use this prototype field, and then you can add properties, and those properties will be inherited by any object that gets created from this foo constructor. Does that make sense? Question on this slide? Okay. So another example. So here we have another function constructor called myObject, and then we have this to statement. So any object that gets created from it will have a name and size property. Okay. Now we are adding a function to this prototype. So we say myObject dot prototype tell size. So we are adding another property called tell size, and the value of it happens to be function object. So this is in fact a method. Okay. So when I create a brand new object from this function constructor, and I'm assigning to my object, then I should be able to call tell size method. And if I create another one, I should be able to call tell size method as well. Okay. Okay, so this is a bit of more explanation. You know, I'm gonna just repeat how things work underneath. So the underscore prototype provides inheritance between object instances, only between object instances. Okay, so we need inheritance in JavaScript, something like Java class level. So in Java, an object that is created from a class inherits all properties and methods of that class. Also in Java, if you create a child object from a child class, then any new Java object created from the child object have the new properties and methods of the child class. In JavaScript, there is no concept of a class, as I said before. So constructor function plays that role, however. Okay, so from a constructor function, you can create an object. Okay, so you can think of construct function is a template object. Okay, from which you can create a JavaScript object. So if we add properties to that constructor function in JavaScript, we want new objects to inherit those newly added properties. So that prototype field of a constructor function creates an intermediate object called the prototype object. So that's basically what I'm talking about. This guy. This is the intermediate prototype object. Okay, and any object that gets created, then any object that gets created, the underscore proto field of that newly created object will point to this intermediate object. So that's how things work underneath. Okay. All right. So that's exercise 2. So let's take a look at exercise 2. So this is basically the same code. Okay. I showed you in the presentation. Okay. So we're just adding x and calculate. And you can certainly take a look at the foo here. You can see. So let's actually dissect, inspect of this foo. So this is the prototype constructor 3. So we want to take a look at this foo first. Okay. Now this is a case that we have inspecting this foo, and we are adding this prototype field after that, right? Okay. So we can see this foo and this foo is the same thing. Okay, so we are actually inspecting this too, and it should result in the same. Okay, so let's actually take a look at that. F12. Okay, so you can see it does have should have let's see. It should have x, and so basically we should have this prototype field, right? And prototype field has x and calculate. Okay, so calculate and the x here, and it does have its own prototype. Okay, and the same thing, it should be the same thing. Okay, so prototype field has calculate and x here. Now, when we create brand new object from this foo, we have a B and C, and when we inspect those two, so when you inspect those B and C, this is the foo object, right? And you can see it does have a proto field, and it's actually pointing to this foo, the constructor function. Okay, so if you just click this guy, you can see it does have in fact the calculate and x. Same thing for the second object C is actually same thing. So C should have, this is the C object, and it does have its own y, and then it does have a proto underscore proto field, and it's actually pointing to foo function object. That foo function object has calculate and then x properties. Okay, let's see. This one, I expect this one as one of the properties, but it looks like this is the constructor. Okay, so I have to understand this one a bit. So the key point is that underscore proto field of newly created object is basically pointing to function object. Okay, so that is the exercise. And this one, yeah, so this is another example. So we have tile size and function, and yeah, so this is pretty much the same code that we have seen before. Okay, and here we are also exercising the get prototype. So this is the same thing as accessing underscore prototype field. Okay, so here we are basically the assigning tile size 2. So instead of actually doing that particular object, this is the case. We are basically my object. Oh yeah, so this is the case that we are assigning function object to the underscore proto field of this my object, right? And so instead of using underscore proto, we are using this standard API. Okay, so let me actually try prototype constructor 4. So prototype constructor, yeah, so this one. Okay, so if you run the code, and everything works okay. So what the point is that this is the same thing as like my object dot underscore proto underscore. This is the same thing like this. Okay, so if you save the change and if you run it, and it should work exactly the same. Okay, all right, so I'll let you do this exercise, and if you have time you can do this homework as well. So right now is 16 minutes after 4, so I'll give you rest of the today. So we're gonna end our code camp at 4:30, so we have 18 minutes, I'm sorry, 13 minutes to do this exercise. Okay, so let me just